All right, we're back here to talk more about NaaS, right? I think you probably expected that. And we're going to talk about NaaS and the other hot topic, AI. So when you have both in a sentence, you know it's going to be really good or really bad. And to do that, I would say we have a bunch of panelists that are experts in AI, NaaS, and multi-cloud, right? So let's bring on our first guest here. We have Mirko. So Buddy's, I know Buddy's on the agenda, but Buddy Bayer couldn't make it, unfortunately. In fact, instead we have Mirko Bortolini from Code. Let's welcome Mirko. And next we have Maurice Dean, who is Director of Product Management and Network Software and Platform from Equinix. Maurice. Now, next up we have Usman Javed, who is the Chief Products and Marketing Officer at Orange Business. And finally, you know him, you love him, everyone knows Daniele. Welcome on stage. In case you don't know, he's from Sparkle. All right. All right, gentlemen, here we are again talking about a couple of hot topics. We got AI, we got NaaS, and we threw in multi-cloud just to have sort of keyword salad. But it is real. There is a real thread here that I think will be useful, hopefully to the audience as well. So we're going to start and talk about how is NaaS today being leveraged to optimize AI workloads across multi-cloud environments. Notice how I got all three keywords in that question. And what advantages does NaaS provide in terms of cost, performance, and scalability, which is what enterprises do care about. And so certainly, we don't have to talk only about AI. I know you've heard enough about AI. You can talk about non-AI workloads as well. And to do that, we're going to have Mirko. Ready?
Yeah, ready.
Go.
So actually, there's been quite a few talks about what are we actually defining as the AI workloads. But just as a recap, there are two types of workloads, training and inference. And we see data being scattered. Actually, one of the sessions also earlier, the ELC session talked about SaaS, cloud locations, multiple clouds, on-prem data centers. So you see this entropy of data all over the place.
Right.
That needs to be brought back to the model for the training. And this generates significant amount of traffic in a complex multi-cloud environment. Then there is the inference, which is many order of magnitudes higher in terms of number of workloads, but smaller bandwidth. But if you look at the whole of it together, it's actually much larger than training data. But it's much more complicated in terms of where. And we see also inference being moved more towards the edge. Also, again, latency being requirements. So two types of traffics, but a very complex multi-cloud or multi-location environment. What is the role of NaaS here? We see today primarily this ability of the easy button, we call it, to create, instantiate a multi-cloud private wider network. So primarily at layer 2, layer 3 level. The network at that level gives you the flexibility to reach in all the locations in an easy way, all the on-ramp locations. So that is the power of NaaS today. It provides that level of flexibility, the performance, the scaling ability. You can actually flex bandwidth up and down, so as the traffic moves, even automatically you could do that. And also security, also other sessions talked about how you can actually encrypt the traffic. So that's definitely the capability. API also, I think not everybody owns all the data.
Yep. No, I think that's fair, and I think what you pointed out is important because AI workloads are not there's different types of AI, and there is other AI as well, right? Which is it's not just generative AI, right? There's also other elements of AI, and we used to call it big data analytics. We used to call it predictive AI. That hasn't gone away. In fact, that's still important. Even as we make new cat videos and write limericks and poems that that are maybe useful to us and entertain us, but it's going to raise the degrees, the raise global warming by 0.0001 degrees Celsius every time you do a cat video, right?
Yeah.
I mean, yeah. Right. I know Daniele does it all the time, right? Cat video. No. Maybe less than Frank. Right? I know Frank all the time, ChatGPT. We know that. Right?
Exactly.
Yeah, he's warming up.
He proved us.
Yeah, exactly. So, yeah, he's right there with his scarf. Yeah, he's ready for global warming. Anyhow, so speaking of training and speaking of inference, I know that's the two main types of workloads that we talk about. And Maurice, as someone who actually knows also the infrastructure, right? I mean, Equinix is used in terms of moving data around across multiple clouds, multiple locations. What are you seeing in terms of the sort of infrastructure changes? And are there differences? I mean, Mirko touched on some of the differences in NaaS, right? What are you seeing at Equinix? You work with the telcos, you work with the hyperscalers, everyone's your friend, everyone's your partner. You connect just about everyone out there, that's important. How is AI changing it? How are the workloads, affecting your infrastructure, and what are you seeing?
Yeah, it's a really interesting question. I think picking up on what Mirko absolutely defined really well, that there is a key difference between the training workloads and the inference workloads. There's actually a third which is emerging, which maybe I'll touch on in a moment. Training workloads, as we know, massive amounts of data, right? And in the training environment, in that localized training environment, the technologies applied are focused around high bandwidth, zero loss, and session control, so that let's say the distribution of the workload can happen among that local environment, and often the protocols moving that traffic don't look like pure Ethernet, right? And there's some great work in that space. But I have to say, as Equinix, we don't necessarily see that environment from a networking viewpoint, but what we do see is from a data center viewpoint, from power consumption, et cetera. Where we are really actively engaged is the movement over the long distance to get data to those locations, right? And those have really interesting requirements. Not all AI training workloads look the same. Right. Some workloads are scheduled to be urgently processed. Mm-hmm. Some workloads are, best effort sometime in the next N number of minutes or days or weeks to get there. And so that provides an opportunity for NaaS to help with scheduling. And really that's load balancing. It's balancing across multiple customers with different demands, different priority sets. Another aspect is security. Security in transport, right? Where we look at technologies like MEF-CECP, the ability to at link layer upwards and every layer to provide encryption. That's a super interesting set of technologies, particularly when you can do things like key rotation, mm-hmm. right, for each of those jobs. So that gets super interesting. Above that, the areas that we also are particularly interested are separate from security, data protection. But if I can just draw a small distinction, security is if you can see the data, you want to protect it. Data protection might be more, never see the data. So maybe I have an affinity or anti-affinity for certain countries, certain networks that I don't or do want to route my traffic through. Super interesting concept around geo knowledge around transport, right? Those areas are super interesting. There's other features there that I could go through the list, but I won't. But exposing these features, making those features usable, from a user-friendly viewpoint, is how we're thinking about the NaaS experience for customers. I'll switch over to the edge inference. I'll go really quickly. It looks more like CDNs than training models, in the sense that broad geographic distribution, and yes, Equinix are a digital-first, world's largest in the sense of having a distribution that's capable of geographic distribution. So we think of ourselves as well positioned to answer customers' needs.
Yeah, I think you have a lot of
and then the third workload that we could probably start thinking about, very, very nascent, but the agentic AI, where we think about AI agents in this space. Mm. The role of agents in AI going forward looks like an ecosystem, a marketplace, mm-hmm. where a provider of a certain agent may need to talk to another operator's agents in order to fulfill a complete workload. And that looks really interesting. It looks distributed because it has to be low latency between these interconnected agents, and those results have to be immediately available to the customer and requester. And those are areas that we're just starting to see some interest around.
Equinix Fabric for Agents.
Indeed.
Yeah, understood. Interesting. Very, very interesting, with the appropriate protections and all the other necessary compute to run those agents and host them and have that marketplace of exchange, just like you have different traffic today. Very interesting.
Yeah, and the key thing is, how do we make that accessible, and how do we make that usable, right? Without the high cognitive tax of understanding all of the details, how do we abstract that into a framework that is NaaS?
Very interesting. I like that one. That's definitely food for thought. So moving on here, so there is growing demand for AI services. Obviously, we're all talking about it, and certainly, how is AI impacting the design requirements for connectivity infrastructure? Because we view it as again, media and streaming is a dominant workload, right? When short-form videos came along, we had to re-optimize stuff for short-form videos. Now you got AI coming along, regardless of whether it's type A, type B, or type C traffic, with type C being nascent. I just made that up, those labels. Anyway, they don't actually apply. We just made them up. But certainly the network design needs to change as well. And I think there are some inference that are near real time. There's predictive AI in control systems which are actually real time. And so Usman, how are you changing your network design, your connectivity in light of these kinds of AI workloads?
Yeah, I like to bring a perspective of enterprise customers. And I think that this year is, especially talking about Gen AI, is a year of trying some production workloads. And we talk to a lot of customers who are trying to sort of take Gen AI into production, and they find a lot of challenges. And we did a survey of 400 customers who have actually taken the first steps in production. And what we found is that 81% of the customers tell us that they have to rethink their cloud strategy.
Wow.
Because they don't see the data at the right place, at the right quality to be able to feed into production and get the right outcomes they wanted to achieve at the POC stage. We see 43% of our customers who tell us that they have to, given the fact that they need to rethink their cloud strategy, they have to modernize their network as well. Yeah. Almost 96% of the customers are rethinking their cybersecurity strategy. Given the data is all over the place, the network need to manage that and so on. So I think there is a lot of this anxiety about the digital infrastructure that they have today, the cloud, the connectivity, the cyber aspects. Are they really fit for purpose for the AI world? And if you take, and we actually asked them about the type of use cases, and it's very interesting. 80% of the customers told us that they're thinking about some real-time use cases for which they need to have the AI inference need to happen at the edge or closer to where the data sits or closer to the endpoint. And I think if you take a step back and try to think about how the AI traffic is different from a normal web traffic for which we have designed all that infrastructure. I think the best analogy I like to give is a normal web traffic is more like a superhighway, right? Everybody want to get on that highway. Once you are on the highway, you're all trying to get to the destination, which is called internet, and you all consume SaaS services, which would have different types of requirements. And if we take the training type of workload for AI, you can put it in that category, right? Because most of the times you're going to the cloud for that. And how the infrastructure need to adapt, potentially you need bigger pipes because the demand is much bigger, you need bigger pipes for that type of traffic. But when you think about the Gen AI traffic and the traffic which is more inference oriented, I think you need to think about a different analogy which is like a city center. Just imagine taking a bird's eye view of the city center at night, and what you see? You see, the city is buzzing, the cars are trying to get into each other. There is the downtown, which is much more brighter than the rest, and you cannot take your car everywhere, right? You have got specific zones, you have congestion zones, you have got green zones, and what have you. And that is sort of the environment that the customers have to tackle when they're thinking about Gen AI use cases and inference-based use cases. And I believe with NaaS, with the NaaS consumption model, we have the opportunity to bring these two worlds together. The one which is like a city-type environment which is required much more real-time and inference-based, and one which requires a much more cloud-based and multi-cloud centric, and bring that together so that you can offer all different types of use cases to enterprises.
Yeah, I think that makes sense, from a networking, network carrier perspective, right? Trying to optimize for city traffic, and then the other one is, get your highways from 400 gig to 800 gig to 1.6 terabit, right? And on a city center, I think I do see there are use cases for sort of inferencing, especially with predictive AI and control systems. With Gen AI, I'm still, I think the more we'll use it, the more we'll want that near real time. But again, I think near real time is all based on the use case and the workload, right?
Yeah.
I think, I don't know if we need sub-milliseconds or milliseconds, right? But certainly shorter could be better.
I think to Maurice's point, I think he talked about the third workload and he called it agentic. I would rather call it what the scientific industry is calling it LQMs. So it's large quantitative models. If you think about LLMs, it's like they're intelligent, but you still think that they have been trained on a certain pattern of the language.
Sure.
Whereas LQM is the quantitative models, which requires to be doing some computation. And when OpenAI O1 came out, they said it's a different model because it does not get the request and response. It also have the ability to think.
Correct.
That think part of the inference requires a much more real-time experience than you would otherwise have for a normal language-based models. And I think this is where the agents, of course, comes in, because the agents are trained for specific type of quantitative computational tasks to perform a response in time required.
Yeah, I think I think you're right that we'll see more logic and reasoning over time, and that will there'll be different models, different foundation models, different FMs for different use cases, and I think that's what we're going to see. I want to revisit, given that we're going to use these AI models increasingly, and a lot of the IP it's going to be tied up in all these models, and we really touched on it. We talked on security, you talked about security at the link level in MEF-CECP, right, and the ability to do key rotation, and that may or may not be enough. I'm sure there's always more to security, I think, as we've discussed in the past. So security is a concern. We all know that, a lot of breaches. I think everyone's been breached here at least 6 times, right? If you're in the US, right? So your social security number is out there like 6 times over, right? I'm sure all of us. Given that we're using clouds, right, and AI workloads, so how do telcos or NaaS providers, how do we ensure that this kind of data, in the new class of data, AI data, remains secure? Yeah. And considering sort of post-quantum, right, and the new compliance needs, we talked a little bit about that. So Daniele, what are you seeing, and what has to happen for these multi-cloud AI NaaS for security?
Well, I think the key word is data. Data is the most precious thing that customer has, and all this AI-based world basically implies large movement of data and processing and analyzing and manipulating this data. So AI brings for sure pressure on the trust part of the supply chain. Now, when there is a data manipulation process, I believe that first of all we need to be sure that the originating party is really the subscriber, the one that owns the data. Mm-hmm. Think about a practical example. A pharmaceutical enterprise that is using AI to, let's say, to train an AI in order to do diagnosis and prescribe medicines, drugs. So first of all, there is an issue of which is the source of the data. And then there is an issue related to the manipulation of the data. So we believe that from this perspective, identity can be a solution, digital identity can be a solution, and there are technologies and there are activities, even in MEF through the ITN, that could, let's say, address this topic. And operators are uniquely positioned because we are at the beginning of the digital supply chain. We are the first actor to which the data are passing from the subscriber to the next actor in the supply chain. So one issue, but one opportunity is to provide digital identity services for subscribers and for actors in the middle. But one of the main issues is to make sure that during the transport, those data remain secure and remain certified. So today we see increasingly store now and attack later kind of techniques that cyber criminals are using. Attacks that are storing keys so that later on when there will be more advanced type of computing, such as the quantum computer, as you referred, this can be put under pressure and attacked via brute force. That's the reason why it's more than 1 year that we are investigating post-quantum algorithms to secure the connection. And yesterday we launched our NaaS platform with the first use case, that is a quantum safe service. What the customer achieve. At the moment, we provide a fully encrypted connectivity between two endpoints that can be 2 customer sites, can be 2 POPs of the Sparkle network, or can be customer side to cloud. And the customer receive a VNF into the CPE that is combining connectivity and quantum safe cryptography. In future, already in 2025, we will allow through the NaaS portal to order a standard connectivity service, which can be protected with a classical IPsec VPN. And when the customer, for example, wants to run a training session of an AI and therefore wants to be 100% secure that those data are not being manipulated by a bad actor in the middle, he can scale up, activate the quantum safe VPN for the time that is needed to run the workload into the training part, and then scale down again to an IPsec VPN, and so on and so forth. So we really believe that combination of techniques and digital enablers such as blockchain, post-safe, post-quantum cryptography can be really an opportunities for us, telco, to advance the NaaS and the AI space.
Thank you. I think that's useful, and I mean, the reality is that that's useful regardless of, as you point out, it's protecting data, whether the data is used for AI or used for something else, right? That it's
business transaction,
equally valuable.
Absolutely.
You know, maybe you downgrade to just an IPsec VPN when you're watching YouTube videos, but
for example,
but for
from the office, of course.
Yeah, from the office, of course. I mean, that's all. What I mean, look, I mean, anyone who's running. Anyone who's running SD-WAN or SASE, if you look at your stats, I mean, I guarantee you YouTube videos take up the bulk of it, right?
Yeah,
I mean, that's just the reality. I mean, who here doesn't watch, well, okay, let's do the well, no. I was going to say, who here doesn't watch YouTube videos in the office? And
yeah.
Look, everyone does. See, there's no hands, right? I mean, so obviously everyone watches YouTube videos at the office.
We believe that NaaS is not just a consumption model. We believe NaaS is much more.
It's an
flexibility,
active,
digital experience.
Yeah.
So we want to provide customers with the ability to choose what is best for them time after time.
I think that's fair. I think NaaS needs to evolve into, I mean, NaaS should be an active network that is based on the workload and the business goals that you're trying to achieve.
Right.
And the network should react to that in whatever way is appropriate for that, right? And so speaking of that, you know, I mean, before we run out of time here, I wanted to get sort of each of your points about sort of look ahead, right? So we've talked a little bit about how the network is starting to shift to adapt to AI workloads. The next 12 to 18 months, right, just besides sort of post-quantum or PQC, how do you see NaaS evolving to adapt to the different types of AI workloads? You know, what do you see in the near future? You know, whether it's, you know, inferencing, whether it's training, or whether it's enabling an agentic hub, if you will, right, type C traffic, right? So what do you see? Anyone want to go first? Anyone's ready with the right answer? I think Usman's got the right answer, so you go ahead. Yeah,
we'll grade you on that.
He's launching himself.
Yeah. He's ready to go.
Repeat ourselves.
I have two explicit things. I think, we like to put that into perspective of what is network for AI and what is AI for network.
Right, sure.
I think for AI for network, which is using AI to be able to offer a better network experience, better NaaS experience, I think we have a real opportunity to build the digital twin of our networks.
Sure.
And then use that in order to create this cyber, security graph of the network to be able to start predicting the cyber threats. I think in Europe, we have a lot of new regulations coming up, DORA, NIS2, and so on. If we are able to simulate the network environment through the digital twin and be able to say where we achieve compliance risk and issues, could be really high value for enterprises. Mm-hmm. More from the network for AI perspective, I think the networks of the future need to go from the networks for routing to do network for reasoning, which means that in the future, all traffic is going to be AI traffic. And majority of that would require very fast inference at the lower cost possible, and lower cost possible, fast inference potentially at the edge. In order for that to happen, you need to have a very inference optimized routing capability. And then your NaaS should not just be routing, but also do some compute and processing.
Sure.
So that you don't just rely on those AI farms, because that may not meet your latency budget that required for the application. So I think these are the couple of opportunities.
Yeah, correct. That's fair. And if you call Calm, you say you just run on the device, right?
Yeah.
Yeah.
Well,
that's the lowest
you
latency.
would, right? I mean, you can and you should.
Yeah.
But then there would be many use cases which would not be tolerating, and it's not just about performance.
Yeah.
It's also about regulations. It's about data compliance, and also it's about sustainability. I think this is a topic that we miss out a lot when we talk about Gen AI. We think, okay, we're not going to talk about sustainability, but it's a big topic for enterprises.
Yeah, no, it is. It is. I mean, we're all going to burn at some point when we use too much Gen AI, aren't we?
Yep.
Anyway, okay, who's next? Now that Usman's given the correct answer, who has an alternative correct answer?
Well, I can talk a little bit about how we're thinking at Equinix. We're very much in a listening mode at the moment.
Sure.
Right? We're trying to understand where the customers are, and how do we meet them. We know a couple of things. We know that we need to abstract complexity from and use concepts around NaaS to do that. Declarative APIs, intent-based work scheduling, right? Making sure that we do, I know it sounds a minor thing, but consolidate the access points into how our customers can configure their services. It sounds very minor, but this is a key stage before the complexity of building out broader NaaS workloads. And so, we're very much in listening mode at the moment, which then we will hope that we have got the right solutions around how we adapt to where enterprises are.
Yeah, I think it's fair. I mean, everything's evolving very, very quickly, right? What we know about foundation models is changing by the week. And
Exactly.
That's
a couple of things. I already mentioned inference at the edge, so moving workloads closer to the users. I think we've seen that happening with machine learning in the past, and main applications like computer vision in proximity of production equipment. That's going to happen also for inference. And I think it's a good point about distributing that inference into multiple different agents. Second thing, we also call intent-based networking, the ability to control traffic in a way that allow the path to be optimized for certain parameters. Could be sovereignty, again, Maurice mentioned that as a use case for data in motion, but also green networks, trying to avoid hotspots for high energy consumption, carbon neutral type of path. So that kind of granular control of traffic can be quite useful to these use cases.
Yeah, I think that makes sense. And I think the reality is that the routing is going to get more complicated. As data centers seek power, right? Desperately seeking power is what's happening right now. And it's got all these new places, and you don't always have compute available, right? That's the problem. Exactly. Right? GPU is in short supply right now. I got a couple here. Anyone want to buy some, right? but I mean, it is in short supply right
Absolutely.
now. Right? So Daniele, well, close us out. We have, the rest of the time is all yours. We're being very generous here.
Well,
1 minute, 30 seconds.
If I think 5 years from now, I believe that there will be AI deployed in the server farms, as Usman was saying, but not only. I assume that there will be AI agents running in phones, in universal CPs at customer premises, edge locations, points of presence, data centers. I like to believe that all data that will be collected and analyzed will make sure all those different AIs will be able to collaborate one another. So to create, let's say, a NaaS that is already driven by the AI in order to support better AI workloads. In other terms, I believe that network security and anything else that NaaS will evolve in the next future will self-heal, will self-design, and will activate in order to better support the customer workloads. It's not supposed to be anymore our customer to tell us when he wants to run inference or when he wants to run training and ask via API or via web portal to adapt the network, but it will be the network itself, because through those agents will collect the data and activate the network to support.
Yeah, I like that. I like that view, which is that the type C AI, the agentic AI, is the one that invokes the NaaS API to say, I need to connect to this service, give me this kind of SLA, because this is the kind of whatever workload or whatever thing that I'm trying to do on behalf of my humans.
Exactly.
That I'm now ruling over, right?
And this will blur.
Supporting. Supporting.
This will blur a little bit this strong difference that we are making today between training, between inferencing, and so on and so forth. I believe that there will be a kind of edge to cloud continuum that will allow this vision of the network.
Excellent, very good. So I think on that note, let's make sure our NaaS APIs are consumable by AI agents, because they will be ruling our businesses in the near future. Excellent. All right, thank you, gentlemen, and let's give them a round of applause. Appreciate it.